Good morning, everybody. Wow, full house. Thanks for coming. I'm Andy Gilbert. I'm from Oracle. I work in the Java Global Sales Unit. We sell Java Embedded and also Enterprise Java as well now for the commercial offerings that we have. My background is I've been in the team at Sun and then Oracle for 16 years now. Originally selling Java into the mobile phone space. So in the good old days when everybody had Java on their phone, now you all have fake Java on your phone, right? So, and the judge officially said it was fake Java. So so we can't do anything about that. But we're still talking about embedded Java. It's still good technology. So I'm going to talk to you about some devices. I'll try and do a demo, although it's crashed on the stand at 9:20 this morning. So we'll see if we can get it working again. But let's get into the session. Usual Oracle disclaimer: what I'm about to tell you cannot be held against me or Oracle. So what are the requirements for an IoT device? So we think that putting smartness, if that's a word, on a device is key, right? So even though we're Oracle and would like you to send everything into the back end, into the database, we recognize that actually having some intelligence on the device makes sense, because sending the telemetry from a car with an accelerometer, all of that data through into the back end is just going to kill the network, right? So I'm sure Vodafone would like to charge you for the data rate, but they don't want you sending that amount of telemetry over their network because it's going to kill the network. So we want to distribute the intelligence. So we want to put it onto the device, potentially a gateway in the middle, and then feed that into the back end somewhere, and that's where our cloud service comes in. You need to be able to connect flexibly to various different options, integrate with business. Of course, you need security. Lifecycle management is an interesting one. The lifecycle management of the devices. If you're going to deploy a device in a car or into a smart meter system for 10, 20 years, you want to be able to manage that device once it's in the consumer house or the network or the factory, and hopefully remotely, so you don't have to send an engineer in to reflash the device. And then we want it to be a service-based platform, so that you can load multiple applications onto that device and have a service-based platform. So it's not a single-function device; it's a multifunction device. We would say this, but it turns out Java is a great technology for this, right? It's already in the majority of the back-end apps. It is there. But there's also lots of devices that already run Java, right? So as a common platform, if you want to create an IoT solution, Java is actually perfect, because you can run it in Java on the back end, you can run it on the device, and it's a common platform where you can share data structures, you can share code across the whole range of the device, of the ecosystem. Just the plug for our technology. So this is the landscape of Oracle Java. So we have Java Card. I'll talk a little bit about that later, but essentially you've probably got a Java card in your pocket already. If you've got a SIM card, or if you've got a contactless card, or a credit card with a chip on, that's very likely to be running Java. ME sits in the middle, and the majority of my demo is actually Java ME. And then we have SE for larger systems. So we can address the complete range of target device sizes. So why do people choose Java for their projects? Well, despite rumours of it being insecure and not very well. It is actually pretty secure. The plugin in the browsers is really where most of the hacks have been, and Silverlight and Adobe and people have suffered from the same, right? So embedded Java and Java standalone is actually pretty secure. You can abstract the devices, so you can have a common Java runtime across all of those devices and just program one application. There's developer availability, so what we're seeing is actually for people to come down from the enterprise and programming Java is actually becoming a lot easier. And we're finding that IoT developers are coming in that direction. They're being asked to program the devices when they're typically coming from an enterprise or a back-end system. We're not seeing a lot of people from the embedded space coming from C trying to then program in Java. They can, but it's usually in the other direction. There's third-party libraries, so Java's been around for 20 years now. You can reuse those libraries, right? So if you tried to do that in C or C++, there's not a lot there. You usually end up having to reinvent the wheel. Just a little bit on ME and SE. So Java ME is actually quite unique because it comes with its own platform framework built in. So it's got its own threading, it's got its own application management system, it does its own memory management. We can access devices through the Device I/O API, which I'll talk about a little bit more in a minute. You only need a variable minimal OS, so it's pretty self-contained. With SE, we generally have to run on a Unix class OS, so Linux usually, and we use a lot of the services from the OS. If you want to have lifecycle management and application management, it's not built into the platform, so you have to do that yourself. And a lot of people use OSGI for that. Other frameworks are available, but OSGI seems to be the main one that people use with SE. So, what functionality do you need from a device? So here's some ideas. So you need access to sensors and actuators. You need to access native code potentially. You want to be able to do multitasking. That's the ability to run more than one service on a device. That hooks into managing the application lifecycle. So they normally go hand in hand. Consistent application environment across all devices, so you don't have to have different skills. You can have the same person potentially writing the back and the front end, or have the same team move around. It's nice to be able to debug the application, so you could do cross-debugging. Security, of course, and then enterprise connectivity. So, access to sensors. So, most devices nowadays, at least dev boards, come with this kind of list of things on there. So GPIO, so access to set LEDs on and off, that type of thing. I2C and SPI are two types of bus system, whereby you can plug in various different devices. They will identify themselves to the bus using a unique code, and then you can know that that's a device ID number 1 or number 10, and you know it's then a accelerometer or a GPS device, and you can then program that accordingly. And of course, serial over UART if required. In the past, you would have had to resort to JNI. And if anybody watched Simon Ritter's presentation yesterday, you'll know the trouble he had getting that running. So let's try and avoid that. On a Pi, actually, you can do two things. So you can use Java ME. And I said that already has the device access API built in, pre-ported to the Pi. You can start programming out of the box to any of those buses and sensor systems. On SE, it's a little bit trickier. You can either use the Py4J library, which is very good, but obviously it only works on a Raspberry Pi. So if you're looking to do something more for production, then you might not be using a Pi. Although I know a lot of people that did try to deploy Pis in production. So, or you can use the Device Access API. There's an open JDK project, and there is a port already for Java for the Raspberry Pi. That's the reference port. If you're using other devices, so the devices I've listed here, they're basically the ones I've got in my little case. You can't see it, unfortunately. This doesn't drop down enough. I've got a Freescale board. I've got a Raspberry Pi. I've got an ST Discovery board. And they all run Java ME. So you can use, the Device Access API out of the box. For SE, you're going to have to port the Device Access API yourself. So the code's there, but you're going to have to do some low-level coding because it's not Java code. The Device Access API, it's C or C++ because you're hacking it. You've got to go into the native device. I'm at a dev conference. I had to throw some code in. That's the only slide with code on it. I'm sorry for that. But basically, if you want to access an LED using the Java ME Device Access API, you basically create a device manager, you open it, and you pass in a GPIO pin config. So 6 is the number of the pin. I want it to be output only. I then tell it what the mode is, so we want an output and we want it push-pull. I then have a button, which is the same, and I want that input pull-up. And you can set a trigger. So basically, the trigger is essentially, if you press the button, do you want it to trigger when you press it, or do you want it to trigger when you press it and then release it? Right? So these are the things you have to decide. And it can be quite tricky when you first start programming it because you think you want one, and then you go, no, actually that didn't work the way I wanted it, so you have to change your trigger. And then you open that up, and off you go. An LED port is a special type of LED. So you can set up a port which is a number of LEDs in a bank, so you can write in one go to multiple LEDs. So if you wanted to set some kind of flashing system going, you would write in one write to the LED bank rather than individual LEDs. And then we just set up a listener. So we've got that GPIO pin. We set a listener on that event coming from the pin, and then you can see here I just basically if we get a button event, I just set the pin to opposite to what it was, the LED. So it's flashing the LED when you press the button. Native code from Java. Try not to do it, I would say, but sometimes you have to. So in SE, we have JNI. You can use a tool to basically create references, and then you have to import that the header file into your C or your C++ function and compile it. But you have to make sure everything matches up properly. Otherwise, it can get some race conditions. I'd say I would use the device I/O, but sometimes people's native code is some algorithm, so it's not always accessing hardware. It could be that you've got a cryptography algorithm that you just don't want to port into Java, right? So you've got to interface into that somehow. ME, in the old ME, we used to have a thing called the KNI, which was the KVM native interface. Doesn't seem to be available anymore in Java ME 8. So you pretty much you have to find another way of doing that. So ME's not good if you have native code that you want to access outside of hardware. Multitasking. So Java's done that from day one. So with threads and runnable interface, try doing that in C. Right. So if you want to create a thread in C, it's pretty tricky. You have to have some other kind of framework that you're calling underneath that. In SE, from JDK 8, so before JDK 8, you could use the fork join framework. In 8, we made that a lot easier because we introduced lambdas and we introduced the streams API. You can now parallelize your code very easily. This is focused more on gateway level devices rather than small devices, I would say. But it is there in the embedded release, so you can program in lambdas. So probably on a gateway level, if you've got multiple streams of data coming in and you're trying to process them, you might want to split that off into some kind of parallel stream. On ME, the concurrency utils aren't there. We left them out because we've tried to limit the amount of the system. So you haven't got fork join, you haven't got lambdas, but that's pretty much the only thing from the language that isn't on ME. Everything else is there. And I say, including this multitasking VM, which allows you to load applications as well as different threads. You can load multiple applications. Managing the application lifecycle. So again, Java ME, you can see I'm pitching for Java ME here. Like, it's great. ME has it built in. So there's the AMS that's built in, which allows you to load, start, upgrade applications and version number them. And it's basically taken from the code that was in the mobile phone. So it uses a jar file and a JAD file, Java application descriptor file, that allows you to set up various information and then download that to the device. New in 8 was the software management API, where we gave people programmatic access to that application management system. So what you can now do is rather than using the built-in AMS GUI or system, you can write your own. So you can write your own application that you load onto the device, which then manages the install and uninstall of programs. They're all isolated from each other. So the potential to have multi-tenants on a device is actually something that you can really say you can do. So the device doesn't necessarily have to have the software just from one person or one company on there. You can offer out that device to other companies to say, well, why don't you run your app on my device? And you can modularize the software as well. So you can break it up into services. So you can have a service for accessing the, let's say the UART, and everybody else just hooks into that service. SE, so it's a little bit of a castaway here, but I use OSGI. I don't want to go into the whole OSGI system here because it'd take ages, and I think most people know what it is. A little bit more on ME modularized software services. So there's basically you can partition your software into different modules, and so essentially you can start to write applications on a device a little bit like a SOA model on the back end. Yeah, so you can have services and then you hook into those services. And that obviously enables you to have faster, more flexible software development. There's also this potential system of multiple client domains, partitioning. So this is something in ME that basically allows you to have separate security domains for different applications that you load into the system. And again, this helps with this multi-tenancy idea of allowing different people to access the same device. Consistent environment across devices. So I already talked about this a little bit, but the idea of basically having the same platform on the back end as you have on the device side is a good one. But also, if you're in a team where you're programming and you've got different hardware from different sources, you can basically just write an app once and then run it on those different devices because Java's already ported to that device. So you can replace or update the target devices without rewriting your code. So if you have a hardware refresh, you've got Java on the device, you don't have to redo your application. Just quick talk about debugging. NetBeans or Eclipse, whatever your choice is. We would say NetBeans. I don't know if the NetBeans guy's in the room or not. But yeah, you can connect into a running device, you can single step, you can do all the stuff that you know about. The nice thing on an embedded device is if there's some kind of watchdog or if there's a driver running and you want to test a system, you don't have to stop those other threads from running. They will keep running. And you can then just debug your thread that is consuming that data. Security. I've got quite a few slides on security because we think that is key. The security of the platform is key. So in Java, there's several options here for security. So first of all, there's the language security. So you've got type safety. We've got the bytecode verifier that basically checks the code as you load it in. If somebody's done a man-in-the-middle attack and tried to change something in that bytecode, the bytecode verifier will spot it. And we do automatic memory management through the garbage collector, which can limit buffer overflow attacks and that sort of thing, because basically the garbage collector is managing the memory. The sandbox has been there forever, so everything is run in a sandbox. You have to now sign your code, and we load those classes securely. And basically, it's type, and then with the security policy. You can basically set fine-grained access control onto what you can access on the device based on the signing and the policy. And then security APIs, we have cryptography built in. This is TLS 1.2 here, is there now in both ME and SE, so you can use the latest communication security. One of the nice things about Java is the security model is built into the platform, so you're not reliant on the host OS. You can't see this, sorry, but basically the Java platform has the security model built into the platform. So a lot of the time, if you're porting code natively and you recompile it across applications, you don't take into account that maybe the security model of the OS you're recompiling to might have changed. So you're potentially creating a security hole there by, you think, oh yeah, I can just recompile for this new device, off we go. With Java, the application and the model is built in to the platform, so the host OS is kind of doesn't really matter. Code signing. I won't go into great detail here, but essentially, we sign the code. You can make sure, especially if you're going to open the device up to third parties to access, you can sign that. Prevents tampering of the code in motion, so any man-in-the-middle attacks can be blocked, and you can really protect your code that way. Java access control. So this is a policy. Again, you can set fine-grained permissions through the security manager to exactly what services of the host you're going to access. So again, you're locking down that device to say, no, this is the only thing that you're going to access on the device is this. Right. That security is available across all of the platforms, so SE8, ME, and Java Card is extremely secure. The cryptography architecture, this is an interesting one. It's built in to Java SE, but it also allows you to provide your own crypto provider. So you can use the Sun ones, or you can provide your own. Or you can even go, this is software or hardware, it's saying here. So basically what you can do is you can have a secure element on the device, Java Card or other, and you can then configure the Java to the crypto provider to be that secure element, or to take the keys from that secure element, so that you're basically storing all your keys in a secure, tamper-proof environment. One of the things we can do then is we can do secure boot of a device, for example. So if the secure element isn't plugged into the device just won't boot, or you can't access the secure file system that relies on the keys in the secure element. So you can start to secure that device. ME is slightly different. It has this security and trust API built in, and that is how you access the secure elements. The connections are still there, so we have full TLS support 1.2, and there's now in the latest release, you can't see this, sorry, on here it says there's now a secure file system built into ME as well. So we take some crypto keys from an element as we boot the device, and then that file system is secure. A little bit about Java Card. So I don't know if you're familiar with Java Card, but basically it was around for years. It's specifically ported to SIM-type devices, so smart card devices. And the way it's certified is the hardware and the software is certified together. So it's not something you can just load onto any old chip and run. The manufacturers that make Java cards go through a rigorous security procedure, and they certify the whole platform to EAL 5 level, which is pretty high in the common criteria status. So they're pretty tamper-proof. They put various tamper proofing systems onto the hardware as well to stop people applying voltages to the card to try and get it to spurt out its secrets and stuff. So it's a pretty good place to store your secure keys, etc. So I pretty much said that. Enterprise connectivity, well, Java, that's what it does, right? That's why it's got a good solution for moving on to the device. What we typically see is two types of models, either a REST-based model, so either a HTTP or HTTPS or CoAP. I found out as a small protocol for talking to devices, that's a REST-based protocol as well. Or some people go with the message queue-based model, so you can either use a JMS provider, or a lot of people in the device space we're seeing is starting to use MQTT, which is originally from IBM. Now I think it's Eclipse project now, and that's a lightweight message queue protocol for communicating between devices. A little bit about our Internet of Things Cloud Service. So once we've got that device running, we then want to connect it into the cloud, and we want to onboard that data. So Oracle just launched the Internet of Things Cloud Service about 6 months ago. It's a way of onboarding the data into an enterprise environment. So one of the things you can do is basically so you can connect your device So it gives you a endpoint management. It allows you to authenticate that device into the system using OAuth, and then it virtualizes that device. So that's our connecting in. Once we've got that device connected in, we then, in the cloud server, we have real-time analytics in the stream. So we have this stream processing. Data enrichment is kind of contained in there, and an event store. So what we can do is, as the data passes through, we can apply filters and functions to the stream to enrich that stream. So, for example, you might apply data from a third-party source that says what the weather was like today, and attach that to data coming from a system that's giving you temperature of a device. So you can correlate the two. So you can say, well, yeah, the device ran hot today, but actually it was 30 degrees outside, so maybe that's all right, right? So that correlation, data enrichment, added in the stream. And then that can then all be passed through into the back-end system. It can be into an Oracle cloud system, so we have our Oracle big data system, Oracle database in the cloud, we have Oracle analytics in the cloud. But if you use the integration cloud service, that allows you to then pass that onto any system of your choosing. So you could pass it through into your own on-premise system, you could pass it through into Amazon Web Services system, whatever, right? So the cloud, the IoT Cloud Service is really about just onboarding that data into a form we can then pass it into an enterprise system. So, for example, if you've got a telemetry from a car and it's saying you're doing bad driving, you might pass it on to a system in the back end that then sends through a message to tell you your premium's gone up because you drove like an idiot for the last week, right? So, or if you have a crash, it might dispatch the police or a AA man to pick you up, right? I don't like builds. The way you can connect in, there's a couple of ways. So we published the REST APIs for the cloud service. So you can code on your device just to that REST API and connect in and you're up and running. Or what we've also done is we've open sourced the client libraries. So we've published some client libraries in Java, but we also recognize that we need to do others. So we've got C, we've got Android, we've got JavaScript. There's one other, I can't remember. That's all open sourced. You can download that from the website and you can compile it into your application. And then that gives you the ability to connect into the cloud service. Right, demo. Right. Now this was working until I see Simon at the back there. The demo gods have got me. My cloud service was running until about 9:20 this morning when it suddenly decided to delete all the keys off the devices. So all my OAuth keys have been deleted, so it won't talk to the device anymore. But some of the demo still works. So what I've got here, is this going to work? Try and turn that around. Is that there's three devices here. There's Freescale one. I have a Raspberry Pi and I have this STM. They've all got an accelerometer on them. So, and they're all running Java ME. So, what I have on here is I have just a Jetty server running here locally on my machine that I'm connecting into, and basically this is my front end for my. I've only got the two boards running. So this is showing me all the applications that are running on my device. This is using the software management API that I talked about before. So rather than using the built-in AMS system front end, we've basically put on this application here, application management agent. I can't stop that because if I did, I wouldn't be able to connect to the device. So it's blocked from stopping. That is what this screen, and actually the Jetty server, is talking to to get that information from the device. So this is querying the device directly to find out what's running. So if I want to install and run, say, a data collection agent, I can basically, this one is already installed, so I can run that. And then if I go to my tool here, I've got my accelerometer running, and if I give it a bit of a shake, you can see here that I'm getting information coming in there. If I scroll this down. What we've also got from a local intelligence point of view is the idea of these events. So if I shake it too hard, I hope, yeah, it's just my screen, my PC's dying. We get an event coming through, and then we can do something with that, right? So I don't know why this keeps slowing down. The Raspberry Pi, we have exactly the same application, right? So we can run that same application on the Raspberry Pi.
When you say same application, would it be same source code, just compiled differently? Or?
Yeah, it's exactly the same source code. So if I go into my,
Not even compiled differently, the same jar?
it's exactly the same. There's no recompile or anything. So if all of the code is stored in the web UI, so available applications. So the source code is here, data collection agent.jar 1 and 100, right? So this is the different version here. What we do change though is the descriptor. So the JAD changes because there's some metadata in there that might say the accelerometer on this board is actually a different bus address. But the code is absolutely binary, 100% binary compatible. It's not changed at all. So that's now running. And now you can see we have the data coming through from the Pi as well, right? So it's coming through like that, right? Now, the bit that was supposed to be working was the integration with the IoT Cloud Service, right? So, but that's the bit that got a little bit flaky this morning because my time drifted out, and OAuth is very, very sensitive to time. So if it drifts out more than 30 seconds, it invalidates your keys, and now I can't connect anymore. So, so the idea, we'll give it a try, because I tried reset. As I've rebooted everything, it might have settled itself. So we'll give it a go and see. I didn't want to stop that. Of course, my laptop's decided to go really slow now. Stop. So I have to stop the data collection agent. So if you see at the bottom here, one of the things we have here is these liblets. So the idea on ME is you have this concept of a library application that you can install. So it's a JAD file still that you install, where you specify it as a library, as a liblet. And then we basically have, you can see here, this library here is the driver for my accelerometer. And again, that is the same. So I have the same accelerometer on the two devices, but the way you talk to it is the same. So the accelerometer code is basically the same, and all it does is define the protocol to talk to the SPI bus, because the way you talk to an SPI bus is you send it a byte at a time, and then it sends you an acknowledgement, and you send it another byte, and eventually you get the answer, right? So it's very low level, but once you've got that driver written, you can then have that, and it's in Java, you can then have that at any time you want. We have to stop the data collection agent, though, and to run my event collection agent, because the event collection agent is using the same accelerometer, and it would give me an exception if I didn't. So let's see if this is working. Okay, it says it's authenticated, so we might work. So what I've done here is I've ran that system, and you can see it's authenticated here using OAuth, but it's set up some filters here. So if my driving exceeds 1.5, I'm a bad driver. If it exceeds 2.5, I'm a dangerous driver, and if it exceeds 4, I've hit somebody. Right? So we'll give this a go and see if we get it. No, failed. So you can see here that the OAuth failed because my access token needs renewing because it invalidated my access token because my time drifted out. It's annoying as hell. It's supposed to pull the Pi is supposed to talk to the server and pull the time off it. And my NTP server was working fine yesterday. This morning I started it up and it won't get the time from the NTP server. It just says it's there, it just can't talk to it. So here's one I made earlier. You can see here up until 3:53 yesterday I was receiving data quite happily from the Pi. And now it's auto-renewed and deleted that. Well, you saw it. It was there, right? Okay? And there was bad driving, and there was collision, and there was overturn. So if you turn the Pi over, it gives you an overturn. That data, it was there. You saw. It's just deleted it. Okay. There we go. If I've turned it... Oh, it's come back. Cool. Right. So you can see here, yeah, these are the events that are coming in. So the IoT system, it's not receiving all of the data from the device. It could do. I could stream everything into it, and we could have the IoT Cloud Service filter out all of the crap and then only pass through into the ERP system or the back-end system anything interesting. But what we've done here is we've done that on the device level, and we're just passing through the events. Once that event is in the system, you can then, IoT will pass that on to however you configure it, right? You can see if I go on the dashboard here, this is the actual IoT system that you would get access to. Let me just sign out, re-authenticate. You can see here you get a number of things about how many messages I've received over the last month, how many alerts I've got. It's got a little exclamation mark because it's gone, well, 100 alerts is quite a lot in 2 days, but I've been running the demo. What the device status is. So you can then look at the devices. And this is a list of all the devices I have. This one here should be online, but it's no longer online. So the way you have to do it is you go to registration, you say I want to create myself a registration, you say directly connected device. No, that's stopped working as well. It gives you a code and a secret. You then have to load that secret into the JAD file, load it onto the device, it then authenticates, exchanges keys. The keys get stored securely, and then you've set up a secure device. And then, as you say, the data here. If I wanted to, just to show you the full ME stuff, we can also, if I wanted to run Hello World on my device as well, you can see now that it's popped up in that screen there because this is querying the device and it's saying you've loaded through a different system. You've loaded a new device, a new application, and that's running perfectly fine alongside everything else. Right? So if I show the output, now we've got Hello World coming out of the board, and even though I loaded it from NetBeans, I can stop it in here, It'll probably confuse the hell out of NetBeans, but there we go. So, just finally, otherwise Becca at the back will tell me off for not doing my call to action. Come and play Big Track. Even I'm sure I can recognise half the people that have already done it, right? So, right, we have this on the stand. Come and have a look. If I manage to re-authenticate my devices, this has been on the stand all yesterday, and it'll be on in a minute when I take it back. I'll try and get the device talking again. But that's me done. Thank you very much. Any questions at all? 2 minutes, I think.
Question.
Yeah.
How does it handle low bandwidth environments like 3G or even lower radios?
So the device or
connectivity. So rather than having full internet, where you have delays between the significant delays between the interactions.
yeah. The IoT Cloud Service does handle offline and intermittent connections, but I'm not sure how, to be honest. It's something that was done by a different team, but it does handle offline and when stuff comes back in, like kind of it's designed that it's going to be low bandwidth, and we're not expecting high volume of traffic into that IoT Cloud Service. By the way, it's not a system that is expecting to have high volume not high volume, not high packet amounts. So there's typically the payloads we're looking at 10 to 15 to 50K, yeah, no more, because otherwise you just overload the system. But yeah, the cloud service, I know it handles the kind of the intermittent connection and stuff, but I don't know how it does it. Sorry. Yeah.
Do you have something to gather these events in the device, and when it's online, you push it everything to the cloud service? Like, imagine if I have this device, like, somewhere in the middle of the ocean, and then I get it back.
Yeah, so I think that's part of the offline thing. So if the device is offline, it will store them locally. That's when, if you use the client library, rather than writing your own using a REST API, the client library has got that built in. Yeah, it's one of the things we've done is that buffer, so that next time it becomes online, it sends everything. Yeah. Whereas if you write it yourself, just using the REST API, you've obviously got to implement that yourself, right? Yeah. All right, guys. Thank you.